last week we do an analysis about the boat, right? Boat connection, the different steel plant. Okay, and this case I believe this later we will discuss about this case. Okay, now we continue to do this study. Sometimes for here we can see different members were connected by the boat, and for other case we will fix the boat connection and torsion and torsion. For this for under torsion we have
I want to get Dennis.
okay.
Dennis. You've been quite a lie. No, I was in Dennis. Okay, boss.
So when both connection and torsion how to analyze for this case? Try to think about it. You can look like do you know this case? Dennis. A moment was applied on this part. Sometimes what's this part? You all know this part?
Isn't that a connection?
Yes, it's also a connection. It's also this is some they have some you can stress this is the support to support the beam, the rails. Okay, right. So when a force applied on here, the loading applied on here, it will make a torsion for this weight point. So this when under torsion, and at the moment it will produce a more complicated. So to analyze it, we firstly to assumption the connection members of a smoothly rotate well the boat is elastic, and each boat rotates around the center. Try to imagine when applied torsion, there will be a center. So every point is applied on the center. Is connected to the center. Then we have the analyze we can build the function to the whole system, make a balance equation. You can see here this is balance conditions for that the torsional force point to the center. This is all the loadings applied on here on the system, and we can find the force of the boat is directly when the force over the distance, the ratio is the same, and for each boat the ratio is the same. Then we can use this equation, take this equation into this balance equation. We can get total force. The total force will be equal to this case. Do you know this? Now, do you know this equation? This equation you can directly use. And according to this equation, we have the torsional force we already know. We can get 1 point, the boat force. And to analyze the bolt, do you know how to, we will check the single bolt force, make maximum force, and then to check it is safety, right? For torsionals, you can see we already know this force we know. For example, is 100 kilonewtons per meters, right? We have get this. We have this distance size. We can directly measure from the part, right? For example, this is 1 meter, this is 2 meters, this is 3 meters, this is 2 meters, this is 1 meter. We all have this distance, and we have this torsional force. According to the equation, we can directly to get the N1T, the maximum N1T, right? The maximum N1T was. So I have a question. What's this? Maurice, what's this? Bolt force for single bolt, right?
Good.
So we have a bolt maximum of bolt force. We can check the bolt force is right compared to the material behavior. The maximum bolt force. Do you know that? This one is come from the what? Come from the teeth, right?
Mm-hmm.
This one come from the lab, the book. So the code. So we can get if it under the contortional condition, it is safety or not safe. Clear?
Yes.
So here you can see N1T will be equal to T. This is calculation procedures. Do you know that? For this one, you can know that, but I not require you should understand it. Okay, if you meet some condition, some question about the joint, it is applied on a torsional force. You can use this analysis method to study this one. Okay. Okay, this is both under the combined action, torsional shearing, and the axial force. Normally, the force we can see this case. They have a torsional force applied over here, normal force, and the vertical force, right? So that means a bolt, the injury with force, the injury bolt is here. It's here, right? So how to analyze it? When they're showing the bolt, we know that. Do you remember how to analyze the showing state? Yeah. Okay. Wait a moment. Actual force, torsional. This one is a question. This one is a question. This one is a question. Okay, we'll come back to see it. So when you get your meet the showing, how is the showing? Right, this is a bolt. Right? Do you all remember this situation? Showing this is broken or this broken. So this is showing we can get a value. If you want to know, I will not repeat again. you can check from the before the videos. It from here, this is the minimal. For example, for here in integers we now named m1 it is m2, right? The nominal m1 and m2, right? This is showing condition. So I have a question: how is the analysis for the normal stress? Okay, normal stress. Actual stress means actual stress means the force is applied. It's applied in this direction, right? Right? You can see that this is showing stress. That means the force is applied in this direction. So we can see here how to analyze this one. I need a volunteer.
Hold me down.
Yes.
Try. Right?
Yes, it's right. It's right. But it's very good, very good. Yes, right. Totally right.
Which this one is for three situations. Is this one and this one, right?
No, no.
So this one is this one.
Yes, yes, yes.
The other one is. We'll get to the other
Forget
one.
it. This is two pieces. I will analyze. Well, I will explain to you. You can see now this is showing stress. The broken will be showing the interface, right? The showing when we when we showing means this is three bolts, three planar displacement in different direction, right? Opposite direction. And here will maybe broken. And also sometimes this face will be also broken. So this is showing. Now when this new case, this is the actual force. For example, we can see here. Now we face it. We check. We meet some different case. If it applied actual force. Actual force means due vertical to the plane, to the boat, and we can find this is F over these areas, right? Over these areas, it will be smaller than maximal error, right? And if you want to write the detailed equation, you can write this one. Remember, this is not a V. This is not a V. Okay. V means showing. Okay.
So in that N.
You can write. You can just directly write this one. Write this equation. You didn't need to remember. Try to remember any equations. You can because this equation is very simple. F over the A. You mentioned just found the A, right? Found the A. For tension, for extension, the A should be in this one, in this part, right? Showing is different. Showing the showing interface will be happen here or also happen here, right? So this is showing. This is the actual force. This is actual loadings. Know that? Okay, now we face the torsion. Here is the torsion. Know that? Torsion means this case. The center we check from this N1, maximum N1, right? The maximum N1, and we using this equation to calculate the N1, and check the N1 is right or not right. Clear? Okay, this is for the case and the torsional condition and a complete condition. You can see here, and the torsional showing and the actual stress. Okay. And we analyze all the force. We combine all the force as here. So smaller than bolt minimum. Clear? We get this one x. This is from the normal stress. This is from the torsional stress. This is from the strain stress. This is from the torsional stress. And combine all the force to get to check the minimum stress, minimum bolt, and compare the bolt compare the code. The bolt is right or not right. So this is the bolt and the shear. You can see you don't need to calculate. If you have any interest, you can do it, and we discuss it after class. In here, we just to know how to calculate this one. You can see, okay, this case, thickness of the 60 millimeters blanket plant with the 8 ground bolt level 8.8 and 18 millimeter thickness of plant. We use M20, D diameter is 20.5 millimeters, Q234B, F steel, check the connection. Normally, we check, we can find here have the 6 bolt applied on here, fixed instilled on here, right? And which bolt is dangerous? For your mind, which bolt is dangerous? Is 1, 2, 3, 4, 5, 6. Which one is dangerous?
6.
Yes, 6 and 1 also will be dangerous. But so we choose a 1 to analyze, and we use the equations. We use these equations to analyze this one. The N1, NT, 1x, NT, Y, 1y. This one, how to calculate it? You can see here. We calculate use this equation. right? Now we through this method we calculate all the equations and check it is right. It is safety on the system. Clear? Have lost.
Not correct.
It's difficult. Yes, maybe a little difficult. So what you can see here, this is about tensional bolt connection. Analyze this. This is effective areas. Sometimes you can see here a force applied on this direction. You can see this 2 volt is extension, right? Extension. We use this F to N over the AE should be smaller than FTD, right? According to this equation, we can get these informations. Understand? I'm not sure if you really understand. Okay?
Sorry, Lao Xing. Could you repeat?
Okay. Now we analyze this case. You can see for this this is means the force is in this direction, right? And you can memorize that one. This one, a bolt is directly applied actual force. Is right? So the principle for this case is we use the force, F force, to over the effective areas of the bolt. Right? Now we can come back to see the case. For here, we can find vertical stress, actual stress. This is a bolt connection, right? That means a bolt for here, for this one, is applied on this force. They have 2 bolts, right? 2 bolts. Now this 2 bolts applied on this force. We use the formulation. For example, this is the F, right? The F, or we mark it is N. Over these areas, effective areas, it should be smaller than what? Smaller than a bolt tensional force, tensional capacity of the bolt, right? You can know this equation. So we can see that A equal to what? Pi R 2 times, right? So we can use this 1, 2. We can get this equation, right? This equation means we calculate the single bolt for this one. Okay. Now you can see it is 2Fn. That now you can see this is the side, right? Side. We choose the side. It actually it will be have a depends on the D, right? This is material behavior. Depends on the level we do the test. So we can get the maximum for this value, right? We combine all this one, then compare to this one. We can make sure it is safety logic, right? So this is the basic principle for the bolt and the tensional stress and the extension stress. Detention force. Can you understand? This is, you can see here, the future, in the meters, this is tension broken, it's on the blue. The truth area is this interface, right? This interface. This interface will be equal to this state, right? Effective area. This is for us to calculate the both group and the actual force. We have the total force. This is total force. For example, we have 100 kilonewtons. This is 10 kilonewtons. We calculate after calculation single. Right, calculated. We can get a number of this one. For this case, this 100 kilonewton for single is maximum is 10 kilonewton. We can calculate this is 10. We should 10 volts to fix it. Is it right? We should 10 volts. Can you understand that? In here, this is your mission to calculate. Okay, for example. You understand? For example, if we have connection, some plants, and a force is applied on this direction, and we calculate a single volt is maximum is 10 kilonewton. 10 kilonewton. But since total force is applied will be 100 kilonewton. So here we should instill 10 volts to fix it. This is this principle. So for this situation, you should know this state. The diameter depends on you. You choose it. If you this side, you will be from the book. You can get this state, and then you can get the single volt maximum force, and to get the number. Okay. Except to the tensional force stress, we also will be face sometimes to meet the moment applied on here. The moment is the same conditions, very close to the tensional, very tensional. The moment, for example, we connection this two part. It also is a blanket support to support the beam or other things. If here we apply a force and produce a moment, right? Which point is dangerous? 1 or 5?
1.
Right? 1 will be for dangerous because it will produce a moment. 1 in this direction, force is in this direction, and for 5, it's opposite. Okay, Now we zoom it. For example, a force F is applied here, not in the center, right? Now we can plot a new figures in the center. For example, the 1, 2, 3, 4, 5 plant. A central force F is here, right? And also have a moment. The F point is applied. right? Is right? This is 1, 2, 3, 4, 5. So we plot the figures. Can you plot the fourth figures for the case? Any Wenqi, can you plot the fourth figures? I will try it for figure for once. For when this plant is only applied on a force of the F, it is this one. Right? Can you memorize this force figures? And if there is now we execute case by this one. And sometimes this one will also produce a force. Right? Do you all know that? Now we can combine these two situations. Sometimes it's like this, right? Or sometimes maybe it will be like this. Or maybe it will be like this one. Is right? It depends on this the value of this one and this. Right? Because in the top, the still one. In the top for the number the first bolt, the force is the same direction, right? The same direction it will be plus together, right? It should be this. And for the fire bolt, it is different direction, right? This is negative, this is positive, so it will be produced three situations. Is right? So we can find which one bolt is dangerous, more dangerous. Which way should analyze which bolt? One, two, three, four, five. Why?
Because one is positive, means okay.
But for example, I will give a value for this one. For example, it is 10 kilonewton. For example, this will be produced at 20 kilonewtons, right? It is negative 20 per kilonewtons. This is positive 10 kilonewtons. For this case, 20 kilonewtons. For this case will be supposed as this case. Suppose negative, suppose as this case. Here have 30 kilonewton applied here. Here have a negative 10 kilonewton. For you, we should analyze which bolt.
One.
1 or 5. One bolt is tensioned with 30 kilonewton. One bolt is only compression 10 kilonewton.
One.
Yes, because it is zoomed a big force together. So normally we can find the first one Do you understand?
Yes.
So we can see here. So now you can see we normally choose the first the one this boat as to analyze the students to check it is right or not right.
So, guys, so a board being over compressed, then have a problem.
Sorry.
So, a board being compressed too much.
No problem.
No problem.
That's when it's being.
So one thing you need to know that you have good questions. I like you have questions. For both. For example, for both compression, extension, strength is the same. Because for iron, for steel materials, the compression strength normally is the same. So you should find which value is bigger. Okay, which value is bigger. So you know how to analyze this case, and we continue to see this. According to this one, we use the formulation to calculate the maximal normal force. Okay, I have